At A, draw a tangent to the circle and produce OB to cut the tangent at C. Sin theta by theta lies between 1 and 1 when theta tends to 0. This is called your sandwich theorem. The value of limit x tends to 0 of sin AX by BX is always equal to A by B. All the terms are of the form a to the power of n minus 1. Suppose if there are two terms, we can write 2 times a to the power of n minus 1. Hello dear students, welcome to this session of Basic Mathematics Revision class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session, I am going to discuss regarding limits continuity of a function. Now, here in this chapter, you are going to get 1 mark question, 2 1 mark questions and 1 5 marks question. So, totally 1 plus 1 plus 5, that's equal to 7 marks. The weightage for this chapter is 7 marks. So, 1 MCQ, 1 fill in the blanks and 1 5 marker question. So, let us move on to the 1 marker question first. Now, evaluate limit x tends to 0 of sin AX divided by BX where a comma b is not equal to 0. Let us recall, we have studied two formulas in this. Limit x tends to a of x raised to n minus a raised to n by x minus a is equal to n into a to the power of n minus 1 where n is a rational number. And another theorem we have studied is limit theta tends to 0 of sin theta divided by theta is always equal to 1 where theta is in radians. Now, what is the problem given? Evaluate limit x tends to 0 of sin of AX divided by BX where a and b are not equal to 0. So, let us convert this into the standard form sin theta by theta. Limit x tends to 0 of sin AX, just divide both numerator and denominator by x. Sin AX by x whole divided by BX divided by x. Now, if you observe carefully here, this x and x gets cancelled. In the numerator, this is sin AX by x. Now, convert, just multiply and divide by a in the numerator. So, this is equal to a into, if you apply the limit x tends to 0 of sin AX by AX is 1 divided by b. A into 1 is a divided by b. A by b is the simplified answer. So, this is an MCQ question. So, the value of limit x tends to 0 of sin AX by Bx is always equal to a by b. Now, move on to the next problem. Evaluate limit x tends to 0 of 1 plus x whole to the power of 1 by x. This is the standard result, standard formula. Limit x tends to 0 of 1 plus x whole to the power of 1 over x is always equal to an exponential value e. So, 1 plus 0 to the power of 1 by 0. That is, limit x tends to 0 of 1 plus x to the power of 1 over x is always equal to an exponent e. Now, move on to the next one. Evaluate limit x tends to 3 of x square minus 4x divided by x minus 2. Now, put x is equal to 3. That's it. If you put x is equal to 3, 3 square minus 4 into 3 divided by 3 minus 2. 3 square is 9 minus 4, 3 is 12 divided by 1. So, 9 minus 12 is minus 3 by 1 is equal to minus 3 is the simplified answer. So, the value of this limit is minus 3. That's it. Now, move on to the next problem. Evaluate limit x tends to 0 of sin 4x by sin 2x. So, this can be written as limit x tends to 0 of sin 4x divided by x both in numerator and denominator, sin 2x divided by x. Now, this can be written as limit x tends to 0 of sin 4x by x. For this, just multiply and divide by 4 in the denominator, sin 2x. For this also just multiply and divided by 2. So, this is equal to 4 into limit sin theta by theta is 1. Again 2 into sin theta by theta is 1. That's equal to 4 by 2 is equal to 2 is the simplified answer. That's it. Okay. 4 by 2 is 2. Now, move on to the next problem. Evaluate limit x tends to minus 3 of x cube plus 27 divided by x plus 3. This can be written as limit x tends to 3 of x tends to minus 3 of x cube plus 27 can be written as 3 cube divided by x plus 3. Now, this is also equal to limit x tends to minus 3 of x cube. This can be written as minus of minus 3 whole cube. Minus into minus plus. Again, this is minus into minus is plus. So if you observe carefully, this is of the form limit x tends to a of x raised to n minus a raised to n by x minus a is equal to n a to the power of n minus 1. What is n? N is equal to 3. What is a? A is equal to minus 3. N a to the power of n minus 1. N is 3 into a is minus 3 to the power of 3 minus 1. 3 into minus 3 whole to the power of 3 minus 1 is 2. 3 into minus 3 square is 9. 9 3 is 27. The simplified answer is 27. That's it. Okay. Now move on to the next problem. Now let us discuss 5 marker question. Evaluate limit x tends to 0, square root of 2 minus x minus square root of 2 plus x divided by x. Now just put x is equal to 0 first. Put x is equal to 0. Put x is equal to 0, then this becomes square root of 2 minus x is 0 minus 2 plus x is 0 divided by 0. So this is equal to 2 minus 0 is root 2 minus root 2 plus 0 is root 2 divided by 0. Root 2 minus root 2 is 0 by 0 form is what? Obtained. By putting x is equal to 0 by 0 form is obtained, which is an indeterminate form. So 0 by 0 is 0 by 0 power 0, infinity by infinity, they are all indeterminate form. So convert this indeterminate form by applying suitable methods. Now just since whenever the problem connecting root is given, rationalize the numerator or denominator. So rationalizing the numerator, multiply both numerator and denominator by square root of 2 minus x plus square root of 2 plus x. Now multiply both numerator and denominator, or multiply and divide by, multiply both numerator and denominator by, so that is root of 2 minus x plus square root of 2 plus x. Rationalizing the numerator. So this can be written as limit x tends to 0 of square root of 2 minus x as it is minus square root of 2 plus x divided by x, the given problem. Multiply and divide by 2 minus x plus 2 plus x divided by 2 minus x plus 2 plus x, that is equal to. So this is equal to limit x tends to 0 of, multiply root of 2 minus x into root of 2 minus x is root of 2 minus x whole the square, minus into plus minus, root of 2 plus x into root of 2 plus x is 2 plus x the whole square, divided by the denominator will be the same, x into root of 2 minus x plus 2 plus x under root. Now what happens? Square root gets cancelled, square root gets cancelled. This can be written as limit x tends to 0 of 2 minus x minus of 2 plus x whole divided by, in the denominator, x into square root of 2 minus x plus square root of 2 plus x. Now this is equal to limit x tends to 0 of, multiply by negative side, minus 2 minus x divided by, this is same, x into square root of 2 minus x plus 2 plus x. Now this is equal to limit x tends to 0 of, cancel the terms which gets cancelled, plus 2 minus 2 gets cancelled, minus x is minus 2x divided by x into the denominator 2 minus x plus root of 2 plus x. Now this x and x gets cancelled. What is left over is, that's equal to limit x tends to 0 of, in the numerator we have minus 2 divided by, in the denominator 2 minus x plus root of 2 plus x. So the intention is to cancel the x, we are rationalizing the numerator. Now apply the limit, put x is equal to 0. If you put x is equal to 0, minus 2 divided by square root of 2 minus 0 plus square root of 2 plus 0, minus 2 divided by root 2 plus root 2, minus 2 divided by root 2 plus root 2 is 2 root 2. So 1 2 gets cancelled, therefore the answer is minus 1 by root 2. The simplified answer is minus 1 by root 2. That's it. This is how we are going to evaluate for 5 marks. Very simple and sure question. Now move on to a similar type problem. Evaluate limit x tends to 3 of x square minus 9 divided by root of 3x plus 7 minus root of 5x plus 1. Now just verify whether it is an indeterminate form or not. Put x is equal to 3. If you put x is equal to 3, 3 square minus 9 divided by square root of 3 3s are 9 plus 7 minus 5 3s are 15 plus 1. So 9 minus 9 is 0 divided by 9 plus 7 is 16 minus 16. Square root of 16 minus 16, that is 0 by 0 form is obtained. By putting x is equal to 3, 0 by 0, which is an indeterminate form, is obtained. So this is 0 by 0 form, which is an indeterminate form. Here also, rationalizing the denominator, just multiply both numerator and denominator by square root of 3x plus 7 plus square root of 5x plus 1. And this x square minus 9 can also be written as x square minus 3 square. This is equal to x plus 3 into x minus 3. Okay. Now I'll move to the next page. This is equal to limit x tends to 3 of, this is x plus 3 into x minus 3 divided by, in the denominator, square root of 3x plus 7 minus square root of 5x plus 1. We are multiplying with square root of 3x plus 7 plus square root of 5x plus 1 divided by the same term, 3x plus 7 plus square root of 5x plus 1. Rationalizing the denominator. Okay. Now this is equal to limit x tends to 3 of, this is same x plus 3 into x minus 3 into this entire term. So numerator it won't changes, 5x plus 1 whole divided by, in the denominator, root of 3x plus 7 into root of 3x plus 7 is root of 3x plus 7 whole square minus root of 5x plus 1 the whole square. So this is equal to limit x tends to 3 of, this is same x plus 3 into x minus 3 into square root of 3x plus 7 plus root of 5x plus 1 whole divided by, in the denominator, just simplify this, square root gets cancelled, we will get 3x plus 7 minus, multiply by negative sign, 5x minus 1. So what you will get, 7 minus 1 is 6, again 3x minus 5x is minus 2x, you can take 2 common factor, this can be written as 3 minus x, or this can also be written as 3 minus x can also be written as minus of x minus 3. So here if you multiply, minus 2 into x is minus 2x, minus into minus plus 3 you will get. So therefore the denominator can be written as minus 2 times x minus 3. Now cancel, this x minus 3 and x minus 3 gets cancelled. What is left over is just apply the limit. Now put x is equal to 3. What you will get in the numerator, 3 plus 3 into square root of 3 3s are 9 plus 7 plus square root of 5 3s are 15 plus 1 divided by, in the denominator we have only minus 2. So this is 6 into 9 plus 7 is 16, square root of 16 is 4, again square root of 16 is 4 divided by minus 2, 2 3s are gets cancelled, this is minus of 3 into 4 plus 4 is 8 minus 24, 8 3s are 24. So the simplified answer is minus 24. That's it. Hope you followed, right? This is how we are going to solve this problem for 5 marks. Very simple and easy problem and important. Now move on to the next. This is a very important theorem. Prove that limit x tends to of x raised to n minus a raised to n by x minus a is equal to n to the power of n minus 1 for all positive values of n. Now using just by division, this x raised to n minus a raised to n can also be written as x minus a into x to the power of n minus 1 plus x to the power of n minus 2 into a plus etc. a to the power of n minus 1. So if by actual division, so x raised to n minus a raised to n if can also be written as x minus a into x raised to n minus 1 into x to the power of n minus 2 into a etc. a to the power of n minus 1. Now, so therefore, this can be written as given equation limit x tends to a of x raised to n minus a raised to n by x minus a can be written as limit x tends to a of, in the numerator, for x raised to n minus a raised to n, we are going to write x minus a into x to the power of n minus 1 plus x to the power of n minus 2 into a plus x to the power of n minus 3 into a square plus etc. The last term is a to the power of n minus 1 whole divided by, in the denominator we have x minus a. So, cancel these terms. So, what is left over is limit x tends to a of x raised to n minus 1 plus x to the power of n minus 2 into a, x to the power of n minus 3 into a square plus etc. a to the power of n minus 1. Now, apply the limit. Put x is equal to a. If you put x is equal to a, this is a to the power of n minus 1, a to the power of n minus 2 into a plus a to the power of n minus 3 into a square plus etc. a to the power of n minus 1. Now, this is as it is, a to the power of n minus 1 plus, according to law of indices, a to the power of m into a to the power of n is a to the power of m plus n. So, a to the power of n minus 2 into a can be written as a to the power of n minus 2 plus 1. This is a to the power of n minus 1. So, this becomes a to the power of n minus 1. Similarly, minus 3 plus 2 is also equal to a to the power of n minus 1 etc. plus a to the power of n minus 1. All the terms are of the form a to the power of n minus 1. Suppose if there are 2 terms, we can write 2 times a to the power of n minus 1. If there are 3 terms, we are going to write 3 times a to the power of n minus. Since there are n number of terms, a to the power of n minus 1 plus a to the power of n minus 1 etc. n times a to the power of n minus 1. So, this can be written as n into a to the power of n minus 1, where n is a positive integer. N is a positive integer. So, therefore, limit x tends to a of x raised to n minus a raised to n by x minus a is equal to na to the power of n minus 1. Conclude this. Therefore, limit x tends to a of x raised to n minus a raised to n by x minus a is equal to n into a to the power of n minus 1, where n is a positive integer. That is it. Very important theorem for 5 marks. Now, move on to the next problem. This is also a very important theorem. Prove that limit theta tends to 0 of sin theta by theta is equal to 1, where theta is in radians. That is the sandwich theorem. Now, let us write the proof for this. Now, let us consider a circle. Now, let us consider a circle with O as center. O is the center. Mark the points A and B on the circle. Mark points A and B on the circle such that angle AOB is equal to theta radians less than pi by 2. Now, this is A. Join OA and OB. And this is theta, which is less than pi by 2. Okay. Let us consider a circle with O as center and R is the radius. R is the radius. So, therefore, OA is equal to R, the radius of the circle. Mark the points A and B on the circle such that angle AOB is equal to theta radians. Now, join OA, OB, and AB is also join AB. Then, at A, draw a tangent to the circle. At A, draw a tangent to the circle. A tangent is drawn to the circle at A. Okay. And produce this OB to cut the tangent at C. Right. At A, draw a tangent to the circle and produce OB to cut the tangent at C. Then, draw a perpendicular. A perpendicular is drawn. This is the perpendicular. BN is drawn perpendicular to OA. BN is drawn perpendicular to OA. That's all. This is the construction part. See here. Consider a circle with O as center, R is the radius. Mark the points A and B on the circle such that angle AOB is equal to theta radians, which is less than 90. Join OA, OB and AB. Next, at A, draw a tangent to the circle. At A, draw a tangent to the circle and produce OB to cut the tangent at C. Finally, BN is drawn perpendicular to OG. Right. Now, from figure, if you observe carefully, area of triangle, area of a triangle AOB, the area of triangle AOB is less than area of sector AOB, which is less than area of big triangle, AOC. So the area is greater for big triangle, then next one is the sector, again then area of the triangle. That means area of triangle AOB is less than the sector AOB, which is less than the area of the triangle AOC. Now just find out the area, substitute and simplify, you'll get the answer. That's it. Okay. Now find out the area of triangle ABC, AOB. Now area of triangle AOB is equal to half into base into height, that is half into base is OA into height is nothing but the perpendicular distance BN. Now just from this triangle OBN, what is sin theta? From triangle, that is from triangle BON, from this triangle, if you write sin theta is opposite by hypotenuse. What is opposite? BN divided by OB, cross multiply OB into sin theta is equal to BN. Substitute here, half into OA into BN is nothing but OB into sin theta. Since OA and OB are the radius, substitute here. So this is equal to half into R sin theta, that's equal to half R square sin theta. Right. So area of triangle AOB is equal to half R square sin theta. Next, similarly, area of sector AOB, this is standard result. Area of a sector is half R square theta. Now find out the area of big triangle. Now area of triangle AOC. Area of triangle AOC is equal to half into base into height. Half into, what is base here? So OA is the base, AC is the height. OA into AC. Now this is half into OA as it is. Find out AC. From this triangle AOC, from triangle AOC, find out tan theta. What is tan theta? Tan theta opposite by adjacent, AC divided by OA. Cross multiplied OA into tan theta is equal to AC. Substitute here. What is AC? AC is equal to OA into tan theta. Since OA is equal to radius, substitute here half into R into tan theta. This is half R square tan theta. Okay. So area of triangle AOB is half R square sin theta. Area of sector AOB is half R square theta, and area of the big triangle AOC is half R square tan theta. Now substitute here. So therefore, now from 1, what is equation number 1? So this is equation number 1. That is, area of triangle AOB is less than area of sector AOB, which is less than area of the triangle AOC. Now area of triangle AOB is half R square sin theta is less than area of a sector half R square theta, which is less than area of the triangle AOC is half R square tan theta. Now what is the common factor? Half R square theta. Just half R square. Divide by half R square. If you divide by half R square, what you will get? Sin theta less than tan theta. That is sin theta less than tan theta can be written as sin theta by cos theta. Now divide by sin theta. If you divide by sin theta by sin theta is 1 less than theta divided by sin theta less than sin theta gets cancelled 1 by cos theta. Okay. Now reciprocate it. If you reciprocate it, so if A is less than B implies 1 over A is greater than 1 by B. If A is less than B implies 1 over A is greater than 1 by. So if 2 is less than 3 implies 1 by 2 is greater than 1 by 3, because 1 by 2 is 0.5, 1 by 3 is 0.33. So 1 by 2 is greater than 1 by 3. So if you reciprocate this, what happens? 1 greater than theta by sine theta becomes sine theta by theta, which is greater than cos theta by 1 is cos theta. Now when theta tends to 0, when theta tends to 0, what happens? This cos theta tends to cos 0, which tends to 1. That is, when theta tends to 0, that is, when theta tends to 0, this becomes 1 is greater than sin theta by theta, which is greater than 1. That means sin theta by theta lies between 1 and 1 when theta tends to 0. This is called your sandwich theorem. Therefore, this can be put in the form of a limit. Therefore, limit theta tends to 0 of sin theta by theta is always equal to 1, where theta is in radians. That's it. So, sin theta by theta lies between 1 and 1 when theta tends to 0. That means sandwich between 1 and 1. So, therefore, limit theta tends to 0, sin theta by theta is also equal to 1, where theta is in radians. That's it. This is how we are going to prove this theorem. Very, very important for the point of examinations. Sometimes they may ask the same question, like instead of theta, they may also ask prove that limit x tends to 0 of sin x divided by x is equal to 1, where x is in radians. Instead of theta, it is x. Sin x by x is equal to 1, where x is in radians. That's it. Hope you followed. So that's how we are going to derive this. Hope you follow. This is called a very important theorem as the sandwich theorem. So these are few problems for 5 markers and a 1 marker. So you may expect you may expect this question for your final examination for 5 marks and some MCQ questions based on this, and limit x tends to a of x raised to n minus a raised to n divided by x minus a is equal to n to the power of n minus 1. Right. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.